Hey guys, so today we're going to be deriving Kepler's third law of planetary motion. Okay, this is probably one of my favorite derivations. Okay, so this is a law where t squared is proportional to r cubed. So what does that mean? So if we have a large mass, which can be the sun, I'm going to call it big M, and we have a smaller mass orbiting around it, little m. So this can be the Earth and this can be the Sun. I'm going to call this distance r, and of course it's going to orbit. And what we're going to assume is circular motion, although it's not really circular, it's elliptical, but in this case we're assuming it's circular. So we're going to use the laws of circular motion for this derivation. So we know that first of all F is equal to mv squared over r. And then we used Newton's law of universal gravitation, which is F is equal to gravitational constant, and then we have the two masses, right? So because these are both forces, we can equate them to each other. So we have mv squared over r is equal to g big M little m over r squared. So we can cancel out some things over here. So first of all, the masses and one of the radius as well. So we have v squared is equal to gm over r. All right, so now velocity is distance over time. Okay, so the distance here is, as we're assuming it's a circle, would be the circumference of the circle, which would be 2 pi r. So we'll have 2 pi r, and the time period is just going to be t. So this is all squared, and that's equal to gm over r. So let's expand this out. So we have 4 pi squared r squared over t. T squared, sorry, is equal to gm over r. And then I'm going to multiply the right side by t squared and the left side by r. So we'll have 4 pi squared r cubed is equal to gm t squared. And now we're going to divide by gm. So we'll have 4 pi squared over gm. And that is equal to, sorry, multiplied by r cubed is equal to t squared. So let's look at this part here. I'm going to put it around in brackets. So 4 is a constant, the pi is a constant, big G is a constant, and our large mass is also going to be a constant. So we can say that r cubed, or the other way around, t squared is proportional to r cubed.